Okay, let's work on a problem in which we are using a sample proportion to estimate the proportion in the entire population. So let me clear off the board so far. All right. Now, Mendel, this guy that worked in genetics, did an experiment in which he had 580 peas and 428 of them were green. So maybe let's underline that in green. So 428 out of the 580 were green, and the rest of them, the 152, were yellow. Right, so that provides me with a proportion. I have 428 out of the 580 that were green, or I have 152 out of the 580 that were yellow. And the problem statement says that I should find a 99% confidence interval about the true percentage of green peas. So because I'm trying to find an interval about the true percentage of green peas, I'm going to use the 428 green peas out of the 580. So that is going to be the proportion from my sample in which I center my curve. So let's go ahead and give ourselves a normal distribution. It's supposed to be symmetric, doesn't really look that way. And I'm going to center it around my sample proportion of green peas, because that's what I'm trying to build a confidence interval about. So there were 428 out of the 580, which gives us roughly about 0.7379. So from his sample data, he's measuring about 73% of the peas are green. The second part of the problem statement says that he predicts that 75 would be green. So he's not too far off, right? Just about two, maybe 1.5 percentage points. Let's use statistics to show whether or not his prediction makes sense. So I want to construct a 99% confidence interval. So I need to move to the left and to the right until I get 99% of the area. So I start at my center of the curve at the measured proportion from the sample data, and I move, so it doesn't look the same distance just because I'm a bad artist, but I move to the left by some error and to the right by some error, where this error is given to me by a critical value, times a standard deviation, right? This is also true for averages. We just use different critical values and different standard deviations. So for proportions, the critical value is going to be a z-score, and the standard deviation of the proportion is p times 1 minus p all over n inside of a square root, where p there, these p's come from where I chose to center my curve, the center proportion of that distribution. All right, so let's calculate this error. I go up to my picture to find the z-score. So if I have 99% in the middle, and I know that the area underneath the whole thing should be 100%, then that means I have 1% to spend in these two tails, meaning that I have 0.5% there, and I have 0.5% in the right tail. Now, to find the z-score that corresponds to this picture, I'm looking for the z-score, and what's this picture look like? If I have 99 in the middle and 0.5% right there, then if I add up all of this area, then the z-score that I'm looking for is going to have 99.5% to the left of it. So I'm looking for the z-score in which I have 95%, or sorry, 99.5% to the left of it. So I look through my critical value sheet, and I find that that z-score is trapped between two values, and we'll say that it's roughly about 2.575. That's the z-score that has 99.5% of the area to the left of it, right? That's the z-score that matches the picture that we're trying to get. So that's my z-score, 2.575. The standard deviation, the p is the 428 over 580. And then I'll take 1 minus p, So if 428 of them were green and the 152 of them were yellow, then 1 minus P would be the 152 over 580. And I divide that again by 580. So it's important that that division is inside that square root. And that's my order of operations. And when I complete this, I find an error of roughly 0.04702. And because I know that this is a proportion, I know that my error is already going to be on the right side of that decimal, right? You can't have a proportion greater than 1. So let's go ahead and collect all those digits. Let's go out to how many do we have? 1, 2, 3, 4, 5 to the 5th place to make sure that we're accurate. So if that's my error, to find my confidence interval, that gives me 99% in the middle, I need to move that error to the left from the center and to the right from the center. So if I move to the left by E, away from the measured proportion P, that is 428 over 580, the p-value, minus that error, 0.04702. So I get 0.690911. And if I take P and I move to the right by that error, I get 428 over 580 plus the error, 0.04702, which is going to give me roughly 0.784951. All right. So that left endpoint, that's going to go right there. This right endpoint goes right there. So the conclusion is we are 99% sure the true proportion of green peas out of all peas is in the interval 0.690911 and up to 0.784951. Or as percentages, and let's round to 2 decimal places, we'll say 69.09% up to 78.50%. All right, so that is the confidence interval. And now we can address his claim. So if he predicted that 75% would be green, do the results make sense? Well, yes. Right? He said that 75% should be green, and 75 is right in that interval. So if we're 99% sure that the true proportion is somewhere in here, and he suggested that it should be 75, then everything checks out. All right. Hope you found this helpful.